Hello guys, in this session, let's try and understand what is a envelope layer. Okay, you may have come across this layer while you've been doing layouts, but then might have not paid attention to it. As you can see from the picture over here, it's a cell-based multi-layer fill shape. So, and here it says fill envelope. This gives you a hint that it's got something to do with the dummy fill. So we know that there are lots of tools what we use to do the smart fill, like the caliper, and there are other custom tools what we use, and we even do the manual fill as well. But then there are some techniques or some way which the EDA companies come up with the techniques wherein they try to ensure that the fill does not interfere much with your actual layouts. Okay, so and that's the reason it creates a boundary around your fill. So what exactly is this? Let's dive into it. Okay, so we know that fill can be of two types. It could be a dummy fill and the in the form of standard cells or in the form of fill shapes. What I mean to say over here is you may have seen that whenever you've got some modules, there is an empty space. Okay, let me draw it over here. Okay. You've got your module, I mean like your complete top level over here, and there's this module and this module over here and this module over here. Okay, let's consider that you want to do the fill for this particular module in this section. For example, you will come across that the tool will automatically lay down some bunch of standard cells of different shapes, right, in the form of standard cells, right? And if you get into this, you will see that all of the layers, whatever are used within this cell, are of dummy type. What I mean to say is the diffusion is dummy, the poly is dummy, other basic base level layers which are used to do the fill are of dummy type. Okay. And that's what the tool does. It ensures that it places all of these cells within these gaps. Wherever possible, wherever there is a large area, it ends up putting uh, the filler cells in the form of standard cells. It could be a long, short, of any dimension. Okay. But the other thing over here is around each of the cell, you will have something called as a envelope layer. So this forms the boundary. This layer over here forms the boundary. This is your actual square cell, which I just drew over there in the paint, and this layer will be around this. Okay. So now, how does this help? This envelope layer helps in manufacturability and smooth transition. We know that even the fill contributes to the uh, capacitance in the design. Okay, and fill plays a very important role, and also CMP process is the one which ensures that the fill is smooth and the required percentage of metal is taken care at every level over here. Now every cell what it places, it has envelope layer around it. Okay, and say let's take one example over here. You've got let me take this. Okay, you've got a diffusion over here. Okay. This is your actual functional diffusion, and this is your dummy. The ones at the right and left are the dummy diffusions, and this is your functional diffusion, for example. So the one thing when it comes to fabrication is be it dummy or be it the functional device. Okay, all the layers are fabricated at the same time. What I mean to say is at that level, say if at all you have got a diffusion which is a part of your functional transistor, and there is a dummy diffusion next to it. Likewise, if you've got a poly, functional poly, and there is a dummy poly next to it, okay, all the similar kind of layers are fabricated at the same time. Okay. Now, if you come back to this picture over here, now this logic over here has got this section has a logical transistors, the actual drawing transistors. Whereas this guy over here has got dummy diffusion and dummy fills over here, right? So whenever there is a CMP process happening over here, there will be a smooth transition the boundary layer, the envelope layer which is there around this, will give a smooth transition for the CMP process, stating that from here on the actual functional transistors start. Okay, it gives a smooth transition. It gives a boundary to that filler cell that this particular region falls under the category of dummy fill. After this over here, this is a functional diffusion. This is again a fill related dummy fill related cell. And another important thing what you want to understand over here is whenever you have this a standard cell kind of a placement of dummy fills over here, you can see that you observe that all of these cells are spaced at certain distance. Okay, the fill is also DRC aware. It ensures that whenever you place this envelope layer and place these cell related fills in the design, they are placed distant apart, that they don't cause any DRC amongst each other. And also, and another thing here is the envelope layer, whenever you draw over here, it places the fill related cell at a sufficient distance from this logic that it does not contribute to any coupling capacitance related effects. We know that fill does contribute, but then the tool is smart enough that whenever it places this envelope related standard cell kind of filler cells, the tool ensures that it places them sufficiently distant apart that it does not contribute much towards the coupling capacitance of the design over here. Okay, this is one such thing what I would like to highlight over here when it comes to web. And as I said, it is DRC aware fill. And another thing here, it helps in parasitic minimization. The distance between the fill and the actual logic is sufficient enough that you don't get into any kind of fill related, the parasitic effects. Okay. Now the other part over here is we have got dummy fills also. One section over here talks about doing the fill with the standard cells, but there are certain minute portions wherein the gap is very less and you cannot place any standard cell over here, standard dummy fill cell. In scenarios like this, that's where the staples come into picture. The tool places lots of square and rectangle staples of minimum area and with minimum spacing, so that the density is also met and the spacing is also taken care. The DRC related factors are also taken care into account. So now the size of these fills, the size and the dimensions of this fill, right? Whenever you open up a fill related cell, you will see structures like this. Okay, so the dimension and the size of all of these things that can be controlled. Here you can see that the fill related shapes are in rectangle form. These are moderate size, these are pretty long, these are small, and these are square over here. Different shapes. This shapes and dimensions of all of this can be controlled by your the CAD engineer can play around with the rule file, some settings, some specification statements which they can code, and you can create the dimension of the fill as well. Okay, so that's about your envelope layer and the variety of fill shapes. Okay, that's where your envelope layer comes into picture, wherein it helps in CMP process, creates a boundary for your fill cell, and does not contribute much towards your parasitics of your design, and also help in the smooth CMP process transition. So this is a short information about the envelope layer. Likewise, we have created a detailed session on dealing with density challenges, analog layout dealing with density challenges on Semionix Academy, wherein we have spoken a lot about starting with what is density, why do we get density errors, what are the varieties of density errors, and you might have seen some of them while working, but there are tens of varieties of density errors. Okay, what precautions you need to take to get rid of density errors, what is the way you can calculate a density even before you run the fill. Okay. We've spoken about lots of these things. You can check out all of those things in this session and even in the description of this whole session over here. Okay, and yes, you can take advantage of all of such courses on Semionix Academy, and we are available on LinkedIn as well. You can follow our company page as well as you can connect with us on WhatsApp chat. If you see over here, we are also available on all of these social media platforms: YouTube, Facebook, Instagram, Mastodon, and the phone numbers and all of those details. Okay, so feel free to reach out to us if you have any queries. Thank you.